Hello, fifth graders. We're going to, trying to get that straight, conduct the inquiry about using the scientific method and answer the question, how does the speed of a meteorite affect the crater it makes? So in this experiment, we're going to create a model to find out how a meteorite's speed affects the size of the impact crater. So every scientific experiment or the use of the method begins with a question. So you're going to ask a question. Will meteorites that move faster make a smaller or a larger crater than meteorites that move more slowly? Remember, meteorite has the IT in it, just like the word hit, which means that that's the ones that actually hit the Earth's surface. So I'll let you think about that for a while and see what you think the answer might be. Okay, so now we actually have to state a hypothesis. The hypothesis is going to kind of give us a guess or an educated guess of what the answer to that question, how does the speed of a meteorite affect the crater it makes, it's going to be an answer to that question. So when you write a hypothesis, once again, another word that should be becoming part of your vernacular, meaning part of your everyday vocabulary when it comes to talking about science. Write a hypothesis by circling one choice and then finishing the sentence. Remember our hypothesis: if, then, and because. So, if a meteorite is moving faster, then it will make a crater with a width that is, do you think it's going to be larger than, smaller than, or about the same size as a crater that's moving slower? And remember, you got to tell me because. Why? Why do you think? So circle one of these, and that's going to be your hypothesis that if the meteorite is moving faster, the crater will be larger. You might have picked, is it smaller or is it about the same size? That it doesn't matter how fast it's going, the size of the meteor is the only thing that matters. Or, so we had a lot of people in class pick it's going to be larger than. And I said, okay, why? And they said, well, because it's moving faster. And I said, well, you've already put that. How does the speed of it affects it? And you said it's going to be larger, and I'm asking you why. Now, in fifth grade words, they said because the meteorite will hit the ground harder. And because this is going to lead us into what we're going to be studying about in chapter 7, I said because the meteorite will have more, or hit it with more energy. So at the beginning of the year, we had this little activity with these little red oriental fish that roll up in our hands, and we had to try to figure out why they did that. And this marble is the model, this metal marble. It has some weight to it. It's going to be our model of a meteorite or meteor until it hits the surface. And it is rather dense. In other words, it's kind of small, but it's relatively heavy for the size of it. The flower is the model of the surface. So, and I just kind of try to, not make it so, I'm trying to make it smooth there. So we have this powdery surface. We talked in class that this is probably the surface of perhaps Mercury, because it doesn't have any atmosphere. And we also said it could be our moon. Now, I think I'm going to see if the kids, I don't know if dragging this across it, so whether it be nice and smooth there, will help and just help us measure. So I'm going to have that nice and powdery planet surface there. Okay, and it says the controlled variables are the things that we have to keep the same in the experiment if you want a fair test. So what will we keep the same? And we just said we're going to keep the meteor the same. We're going to keep the amount of flour the same. Those are two things that are going to be controlled. They're not going to change. Now, the independent variable. Now, see, it starts with the letter I, and it's sort of what I am going to change. I'm going to say it also like I am going to manipulate it. Sometimes this is called the manipulating variable, so I like to call I'm going to manipulate it. Is the variable that you change in an experiment. So if you come back up here, if we want to test how does the speed affect the meteorite, affect the crater gosh, jeepers, affects the crater it makes. So then obviously I'm going to have to, in some way, adjust the speed of the meteorite. So what I am going to change is the speed of the meteorite. And you could call it a meteor because it's not really a meteorite until it hits. Now, the dependent variable, that starts with letter D, and so does the word data. So I have to think, what am I going to record? What am I looking for? It's also called, in some circles, the responding variable. As I change the speed of the meteorite, what am I going to be measuring as far as data? What's going to respond? What's going to change? And I think if you come back up here, obviously we're looking up here, maybe the crater size. So let's write crater size. And that should be done. And then over here, it asks you to draw how you'll set up your model. So I have the box here, and I have it filled with flour, and you could do planet surface. It's as nice as you want it to be. You could put the word flour, you could put both, and we have here, this is just the box, and this is the meteor or the marble. So that's how I'm going to set it, and I'm going to drop that into the flour. But when you come over here, look at some of this equipment here, and we have metric stick and a metric ruler here. I was asking the students, how are we going to adjust the speed? And they said, well, you should drop it from different heights, that would make it go faster the higher you dropped it from. So I was like, oh, okay, so I'm going to draw over here a meter stick, just kind of putting here, and then maybe having the marble drop. Now, remember, another thing that you might want to say that you're going to change, we're not going to throw the marble into the flour. We're just going to drop it. That might be some other kind of variable, the amount of force we use. So now let's list the steps. Let's think about what we're going to do. First, we're going to maybe put flour in the box. I kind of have that done. And then we're going to drop the marble. Now, dropping it just once, normally just it's not a good, what I would say, scientific, valid science experiment. You always have to be, it has to be repeated. You have to have your steps written down so other scientists can repeat them and say, oh, I got the same result. So after I put the flour in the box, and I'm going to drop the marble from 25 centimeters, 50 centimeters, and 100 centimeters, and I'm just going to do 3 times each, and you're going to record the crater width, after each drop, and then we stop there. And we are going to wonder who the heck is. All right. Oh, okay. Okay, and we're going to come over here, and this is where we are going to, it asks us to follow the steps that we wrote, select a tool to measure the width of the crater in millimeters, record the results in your table, and they repeat their test to improve their accuracy. Repeat your test if time allows. So this is what we're going to start. The first part we did yesterday, or when you're watching this video, it'll be yesterday, and we're going to do this. So I am going to say, let's go, if I drop it from 25, 50, and 100, and then this would be the crater width and trial, the width, I guess I should have written that up there, the width of trial 1, 2, and 3. Well, here goes nothing, and this is going to be an average, so we're going to practice that after. But I'm just going to set this aside, and here is my flower that I'm about to make. Here is my meter stick, and I am going to take the, not the 99 side, the 1 side, and I'm just going to put it from here, and we're going to drop it from about 25 centimeters up, and let me see, boom. So it does bounce, but I'm going to see, I can see it right there. It's about the same size, but we're going to measure it in millimeters. Now, this is a centimeter ruler, so these are, that's 10 millimeters to there, 20 millimeters to there. So I'm going to look at this, and I am going to say that that's approximately, I'm going to say about 15 millimeters. So I'm going to go over here on my chart here under 25, and I'm going to write 15 mm. So I'm going to pick this up, and I am going to hold my ruler up, and I'm going to try 25 again. Oh, it does bounce, doesn't it? So this one definitely leaves, like it bounces that. So we're going to have to decide whether we want to do boom and then that one or the initial crater. I'm going to, oops, here I'm measuring with my meter stick. Sorry about that. It's a little bit easier. In fact, it might be a little bit easier for me to use a smaller ruler. So I'm going to go with here and say that was about 20 millimeters. So I have a 15. I have a 20, and I'm going to do 25 one more time. Oh, that was like a thud one. Isn't that weird? Sometimes it bounces and sometimes it doesn't. Oops. And in millimeters, once again, this is about, I'm going to say 16. So I have 15, 20, and 16. Let me show you in my book there. I have those 3 pieces of data down. So I'm not going to show you my book. I'm going to go ahead and I'm going to double the height. Where is my little piece of cardboard here? So I'm going to smooth that out. Trying to get the flower a little bit even there. And I am going to now double that, and I'm going to go from 25 all the way up to 50 and let it drop. Oh, that really, it bounced high too. We saw some of that energy not only leave a bigger crater here, but go over into the second. I'm wondering, so this one looks like, oops, that's nice. I just have to do that. That one's about 15. But I'm wondering, I'm just curious if we have about a cup of flour like in the half of this, whether it'll be more accurate so that it doesn't bounce, that maybe the powder absorbs the crater. Let's see. Let me give that a shot again, shall we? Maybe I'm learning the way that I could do this. Up here, 50, and boom. Boy, I think that that will be better. You could definitely see the difference. So I'm going to measure this one and get it about, oof, that one's almost 30 centimeters. So Take my cardboard. I'm going to get flour all over my desk. So I think I like the flour a little bit thicker so it doesn't bounce up as much or do that second bounce over there. So I'm going to give them maybe 2 cups. So that's going to be really floury here tomorrow. It's going to look like a bakery. All right, here's a second. Oh, it might help if I got it in there. Okay, let me try one more time. And here, boom. Okay, push. So we're going to go like this, and that one's going to be, I'm going to go about 27 or 28. And then pick it up here. Smooth this out. So it's like surface of mercury. That's 1 cup. I'm going to definitely give them 2 cups, I think. So here goes nothing. Measuring from here, and 50 centimeters is actually over the camera. Boom. Oof. And I'm going to measure this one is going to be about 29. Okay, so 29 millimeters. Uh-oh. And now I'm going to do 100. So let's try. About 100. I think it's easier, yeah, when it's thicker. So, uh-oh, here we go. I have to stand up for this. So up here, 100. Whoosh. So even though it's 100, it's still bounced too. Bounced also. So I'm going to go ahead and say that that's about 35. And then I'm going to see if I can make it just a little bit deeper. They, push this down. I don't know if I can get it to knot. Maybe I shouldn't have done it this high. Oh, that missed. Okay. Now you know why I don't place boards. I'm gonna go right up over here. Come on. There we go. So I think the deeper one, it really lets it. Look at this mess I'm making. Oh, this is going to be fun tomorrow. Okay, I think this one is about 27 or 28. And then my last one. My hands are going to be, I need to go wash my hands. Let's see. And this 100 one. I think I'm going to change my drop height for the kids tomorrow to maybe 10, 20, and 30. Let's see. Okay, up here. And here we go. Here's some goes nothing. Oh, okay. Well, that was a long one too. So I'm going to just say that that was about 40. So I'm going to take all of this mess, like in my pants. Look at my pens are all covered with this too. My hands are all dry now. And we will call it about 40. Now we're going to do a lesson on averaging those. And average them, you just kind of add these numbers up. So 11, 2, 4, 5. So 51 is that total. They'll have a calculator. So if you need one, you can get one. 51 divided by 3 is, I believe, 17. I believe. Yes, it's 17. So my average here was 17 millimeters. Over here it was 20, 40, 70, and 17 is 87. So 87 divided by our 3 times, and that's going to be 29 millimeters. And this one would be 40, 60, 90, and 90, and I believe 14 is 104. So 104 divided by 3 would be 34, almost 35. I'm going to round it to 35 centimeters. So when you're looking at your data, you're going to see that yes, indeed, it made on average a larger crater. And then we're going to use your data to make, and I'm going to read it. It says a bar graph, a bar graph. So let's do from, because we're just on this video, might as well stick with ours. Let's do crater size on here. And we're going to do down here drop height. And this is actually supposed to simulate the speed. So we went, I believe, 25, 50, 100. So our average of 25 was about 17. So I got to think about 10, 20, 30, 40. I got to get all the way up to 35. 10, 20, 30. If each of these is 10. 5, 10, 15, 20, 25, 30. Well, they can't be 5. They got to be 10. So this is 10, 20, and 30. So at 25 it was 17. So I'm going to go, well, I guess if this were 10, I'm doing this wrong, and this were 20, it would be a little bit closer to that. And then 50 was about 29, so that's real close to that. And then 100, it was about 35. And then what we're going to do in class is then it says here that normally scientists don't just say things, just like with the development of the vaccine, they share what they found. They compare their methods. What did you do? How did you do it? And we're going to be doing talking with our classmates and comparing our results. But if you study your chart and your graph, what patterns do you see? The faster, or I guess the pattern, the marble travel, and I made a mistake here. It should be the higher the marble fell, or the higher we drop the marble from, because when we're talking about speed, we're going to come down here. So the higher the marble fell, the larger the crater. Describe your results. What can you then infer from our results? That meteors or meteorites that hit the ground at a greater speed make larger craters. Okay. Compare, now you have to like summarize, and comparing our hypothesis, you can say my hypothesis, if you went along with me and thought it would leave a larger crater, was correct. Faster, and you could call it a marble or a meteorite here. Marble left a larger crater or hole. Okay, so we walked through the scientific method. We talked about all of these, the steps, the pictures to understand, make a hypothesis. Then we conducted the experiment more than once from each distance, and then we created a bar graph. Now, this is 25, 50, and 100. I might change this so that it doesn't bounce as much, and they can actually measure the crater. And that's that. So we're going to see the physical science or physics and motion and forces and that kind of stuff. This says here in Unit 2, there's chapter 10. I'm using the thick book. You don't have this. You'll have your chapter 6 is forces in motion, and chapter 7 is changing forms of energy. So there we have it, and I hope that you filled in your book. Have a great Monday.